Good afternoon, everyone. Today is the last day of live sessions, and in this week, Sir has talked about the biofuels, biochemicals, and all the things related to bio-based products. So we'll be discussing or doing assignments on that. I'll be starting in 5 minutes. So, okay, let's start the session. I hope my screen is visible. So, this is the first question. Which processes are included in thermochemical reaction? Which processes are included in thermochemical reaction? Which processes are included in thermochemical reaction? The answer is combustion, not drying, gasification, as well as pyrolysis. So, all these three processes are included in the thermochemical reaction. So it is a multiple option question. So, if you give all the three answers correct, then you will get the full mark. Otherwise, you will get partial marks. Next question. Bio oil is thermally stable. Is it true or false? Bio oil is thermally stable. Bio oil is thermally stable. Is it true or false? The answer is true. Bio oil is thermally stable. Next, how is lactic acid produced from biomass? How is lactic acid produced from biomass? So, the answer is fermentation. From biomass, after the fermentation, lactic acid will be produced. Okay. Next question. Which of the following processes is used to produce terpenes? Which of the following processes is used to produce terpenes? Which of the following processes is used to produce terpenes? The answer is extraction. The right answer is extraction. So extract, if we take biomass and then we do extraction, we will get terpenes. Next question. Hydrolysis of biomass means separation of cellulose and hemicellulose from lignin. Hydrolysis of biomass means separation of cellulose and hemicellulose from lignin. Is it true or false? Hydrolysis of biomass means separation of cellulose and hemicellulose from lignin. The answer is true. Hydrolysis of biomass means separation of cellulose and hemicellulose from lignin. So this is the biomass is here biomass means only the lignocellulosic biomass which contains lignin, cellulose and hemicellulose. So if we do hydrolysis of lignocellulosic biomass, then cellulose and hemicellulose will be separated from lignin. Next question, hemicellulose is easily convertible to sugars. Is it true or false? Hemicellulose is easily convertible to sugars. Hemicellulose is easily convertible to sugars. Is it true or false? The answer is false. Hemicellulose is not easily convertible to sugars because hemicellulose is a five member ring. Okay, that means it has 5 carbons, whereas cellulose is a 6 member ring. That is why it is easy to convert in sugars. Okay, so that is why it is false. Next question, write the name of the simple sugars. Write the name of the simple sugars. The answer is sorbitol, xylitol, and HMS. The answer is sorbitol, xylitol, and HMF. So, these are the name of the simple sugars. Next, biobutanol is more corrosive than bioethanol. Is it true or false? Biobutanol is more corrosive than bioethanol. Is it true or false? So, biobutanol is more corrosive than bioethanol. The answer is true. Okay. The answer is yes. The answer is false. Sorry. Bioethanol is more corrosive than bioethanol. The answer is false because bioethanol corrodes more. Okay. Always remember that bioethanol corrodes more than biobutanol. Next question. Cellulose is cellulose is the liquid component of biomass. Cellulose is the liquid component of biomass. Cellulose is the liquid component of biomass. The answer is true. Okay. So, in the lignocellulosic biomass, lignin is the solid part and cellulose is the liquid part. Okay. Next question. Explain the biochemical process of ethanol production. explain the biochemical process of ethanol production. So, first there is lignocellulosic biomass. It goes into pre-treatment, right? So in the pre-treatment, cellulose, lignin, and hemicellulose parts are separated. So now there are two parts, that is liquid part is the cellulose part and solid part is the lignin part. So now they are hydrolyzed with enzyme that will produce glucose. Now this then after forming glucose, fermentation happens. It produces beer. Then we are doing distillation to increase the concentration, and that will lead to production of ethanol or bioethanol. Okay. Another method is after the pre-treatment, we are producing hemicellulose, right? That will also can lead to fermentation and direct production of ethanol, right? So these are the two basic steps. Along with that, there is catalyst recovery. Then is lignin. There is lignin purification steps are also needs to be done along with the main ethanol production process. But mainly, this is the production method or steps of the ethanol production. Okay. Next, what is the use of unreacted lignin in the production of bioethanol? What is the use of unreacted lignin in the production of bioethanol? So now we have seen in the previous process that lignin is one of the reactant for production of ethanol. So obviously all the reactants, all the lignin will not be converted, right? So some of the lignin will be converted and there are some portion of it will be left. That is unreacted lignin. So we can now purify this lignin and send it back to the reaction, right? Right? This is one step, one process. Another way, we burn the lignin for power generation. That is the application. That is for heat or electricity. Okay. So these two are the ways by which we can use the unreacted lignin in the process of bioethanol production. Okay. Next question. What is biodiesel? What is biodiesel? What is biodiesel? So, biodiesel, also known as bioethanol, is a blend of methyl and ethyl esters of fatty acids that is FAME, and this one is FAME. Okay, so this is the fatty acid methyl ester. This is the fatty acid methyl ester. This one is the FAME, and this is the fatty acid ethyl ester, that is FAEE. Okay, so these two blend uh, forms the biodiesel, and that is also often known as bioethanol. This is the biodiesel. And also you can say that how about biodiesels are produced. So how biodiesels are produced? So vegetable oils and low molecular weight alcohols like methanol or ethanol undergo catalytic transesterification to produce biodiesel. Okay, so first one is the definition of the biodiesel, which is a mixture of the fatty acid methyl ester and fatty acid ethyl esters. And how is it produced? It is produced from the vegetable oils or low molecular weight alcohols like methanol or ethanol. After catalytic transesterification, they produce biodiesel. Okay, so this is the definition of biodiesel. Next question. Biodiesel mixture has a lower oxygen concentration due to the ester group. Biodiesel mixture has a lower oxygen concentration due to the ester group. Is it true or false? Biodiesel mixture has a lower oxygen concentration due to the ester group. Is it true or false? The answer is false because it has a higher oxygen concentration. So the answer is higher oxygen concentration. Okay, and due to this, that it has higher oxygen concentration due to the presence of ester group, that will lead, that is why they burn that means the biodiesel burns efficiently than regular diesel made from fossil fuels. Okay, so as it has higher oxygen concentration, it leads to due to the presence of high number of ester group, and that will lead to the burning efficiently from regular diesel. That is the advantage of biodiesel. Next question: which catalyst is used for biodiesel production? Which catalyst is used for biodiesel production? So, which catalyst is used for the biodiesel production? The answer is sodium hydroxide and sodium methoxide. Okay, so sodium hydroxide is NaOH and sodium methoxide is NaOCH. So these two are the alkali based catalysts are used for biodiesel production. Next question. Acid catalysts have lower efficiency in biodiesel production. Acid catalysts have lower efficiency in biodiesel production. Is it true or false? Acid catalyst. That means biodiesel production process can also use acid catalyst, right? Do they have lower efficiency or higher efficiency? Efficiency. The answer is true. That means acid catalysts have lower efficiency. That is why we prefer to use the alkali-based catalysts that are sodium hydroxide and sodium ethoxide. Next question. What does a FFA do in biodiesel production? What does a FFA do in biodiesel production? What does FFA do in biodiesel production? So FFA is free fatty acid. So vegetable oil contains free fatty acid which are not connected to the glycerol backbone, and they cause adverse effects. How? Now, if the reactions happen between the free fatty acid means this is the free fatty acid, okay, and the catalyst. So what is the biodiesel production catalyst? That is the sodium hydroxide, right? So if they react with each other, what will produce? It will produce right, and water will be separated. So what is this? This is nothing but a soap, right? So if if in the vegetable oil huge amount of free fatty acid is there, it will react with the catalyst and it will produce soap, and a portion of the catalyst is neutralized. So that is how a portion of the catalyst is neutralized and no longer available for transesterification. Okay, so that means the process will lose its catalyst. So if the process will lose its catalyst, then the reaction becomes much slow, right? In the presence of catalyst, only the one reaction can happen fast. So when we are doing the trans-esterification reaction of the vegetable oil, if there huge amount of free fatty acid present, then what will happen? It will react with the catalyst itself, and that will lead to the formation of soap, and that will destroy the or deactivate the catalyst, which is not wanted, right? So that is why we need to remove a free fatty acid, or we need to reduce the amount of free fatty acid in the process or in the production process. Next question. Which chemical changes to FFA in presence of water? Which chemical changes to free fatty acid in presence of water? So, which chemical changes to free fatty acid in presence of water? That is triglyceride. That is the vegetable oil. So how the reaction will happen? Let me show you. So this is the triglyceride, right? This is the structure of the triglyceride. Now this will react with water. Hmm. There is also the catalyst. It will react with water and it will produce diglyceride, that is like this. It will produce diglyceride plus this free fatty acid. So So whatever you have seen that in presence of water, triglyceride changes to FFA. That this is the reaction. This is how triglyceride changes to diglyceride or free fatty acid in presence of water. So in the previous slide, you have learned that FFA is not good for the production, biodiesel production, right? Because it will deactivate the catalyst. But in presence of water also, FFA can be formed, right? So we need to reduce the amount of free fatty acid production, presence of free fatty acid and water as well as water amount. We need to control that. So this is the question. In biodiesel production, FFA and water content should be 0.2% and 0.5% respectively. Is this true or false? In biodiesel production, FFA and water content should be 0.2% or 5%. It is false because the FFA concentration should be 0.5% and water concentration should be 0.2%. Okay, so this is just reverse I have asked. So that is why it is false. Next question, what are the main steps in biodiesel production? What are the main steps in biodiesel production? So the first thing is oil or fats we are taking as our reactant. Then pre-treatment happens. It leads to the formation. Then transesterification happens, right? Then happens the phase separation. Phase separation means liquid and solid part will be separated. Then distillation, and we are getting crude glycerol. So from the distillation portion, the methanol is returned back, right? And one from the top portion we are collecting the, from the bottom portion we are collecting the crude glycerol, but from the top we are collecting the glycerol and we are doing the purification. So here comes the glycerol purification, and so we are producing refined glycerol, right? So after the phase separation steps, there is neutralization of the catalyst. Neutralization of the catalyst. Then, so how we are neutralizing? We are giving acid, that is HCl. Then we are getting salt. Okay, then after neutralizing the catalyst, we are doing washing and drying, and we are getting the biodiesel. So this is our desired product, that is the biodiesel. So from the triglyceride or vegetable oil, we are producing biodiesel by first step is pre-treatment, then transesterification process, then phase separation. Phase is separated, then We are doing the neutralization. One way we are doing the neutralization of the catalyst, and then washing and drying, and then biodiesel we are collecting. And on the other hand, the other part of from the phase separator, it goes into the distillation column. Distillation column. So unused methanol is returned back to the transesterification process, and from the top portion we are collecting the glycerol, we are purifying it and getting refined glycerol, and from the bottom we are getting the crude glycerols. So this is the steps for the biodiesel production. Next, what are phospholipids? What are phospholipids? Phospholipids are the triglycerides produced by a phosphate ester with two fatty acid chains and one side chain. So phospholipids are the presence inside the triglycerides. So we need to remove the phospholipids in order to get rid of the free fatty acid, because we have just learned that why fatty acid in huge amount is not good for the reaction, right? So phospholipids are the triglycerides produced by a phosphate ester with two fatty acid chains and one side chain. Next question. What chemical will be formed in the presence of acid catalysts if there are excess free fatty acid in triglycerides? What chemical will be formed in the presence of acid catalysts if there are excess FFA in triglycerides? So what chemical is will be formed in the presence of acid catalyst? What chemical will be formed? So the answer is methyl esters. So in presence of acid catalysts, if we are using acid catalyst, not the alkali based catalyst, that is NaOH, if we use the acid catalyst in biodiesel production and there is excess FFA in free fatty acid in triglycerides, it will lead to the formation of methyl esters. Okay, not ethyl ester. The answer is methyl ester. Next question. What are the methods to produce pharmaceutical quality glycerol? What are the methods to produce pharmaceutical quality glycerol? The answer is chemical treatment, evaporation, distillation, and bleaching. So crude glycerol, what we have got from the distillation process, it has 80 to 85 volume percent. Okay, crude glycerol can also be used, but if further purification we do, that is by this four treatment, that is chemical treatment, evaporation treatment, distillation, and bleaching, we could get glycerol of pharmaceutical quality, and it has glycerol of pharmaceutical quality, and it that means it has 99.5 volume percent pure glycerol. Okay. Next, which enzyme is capable of transesterification of triglycerides? Which enzyme is capable of transesterification of triglycerides? Excuse me. So, in the biodiesel production, we have used the alkali-based catalyst, that is sodium hydroxide, and the acid-based catalyst, that is. But the thing is that after the neutralization of the catalyst, this process produces large amount of salts, right? So this is one of the disadvantages of the transesterification process while producing biodiesel, right? So the research is shifting to use the enzymes instead of catalysts. So which enzyme is capable of esterification? That is lipase. Okay, the answer is lipase, and it can occur. It can occur or it can catalyze in both aqueous and non-aqueous phase. Okay, so the enzyme is lipase. Next question. What are the advantages and disadvantages of using enzyme as a catalyst in transesterification of triglycerides? So, but enzymatic catalyst also has some advantages and disadvantages, right? So the advantages are, first one is the glycerol can be removed quickly from the distillation column. Okay. Second one, free fatty acid can be removed entirely to alkyl esters. So it will not further react with the catalyst and it will not deactivate the catalyst, right? And third point is inexpensive waste fats and oils. Okay, so they can be treated very easily. So these are the advantages. Now, what are the disadvantages? So the disadvantages are production cost of lipase catalyst is higher than that of alkaline catalyst. Okay, so enzymatic catalyst is highly cost and difficulty in separation of catalyst. So in the alkaline catalyst process also there is difficulty in separating the catalyst, and here also the problem lingers. Okay, so these two are the disadvantages, and these are the advantages of using enzyme as a catalyst in the transesterification of triglycerides. Next question. The yield of FAME is higher while using enzyme catalyst in transesterification of triglyceride. So FAME is the fatty acid methyl ester, right? So the answer is true. So when you use the enzymatic catalyst, it will produce more amount of FAME. Next question. What type of catalyst is required for the transesterification of oil? The answer is acid catalyst. So in the previous questions, we have learned that for biodiesel production, vegetable oil is needed, and vegetable oil, for that vegetable oil, less amount of FFA is present, right? So that in that case, alkali or enzymatic catalyst can be used. But when we are using oils which have high FFA, this type of oil has high free fatty acid content. So these oils cannot be trans-esterified by the alkali-based catalyst. For that, they need acid catalyst. Okay, so the answer is acid. Next question: explain the steps of fuel-grade ethanol production. Explain the steps of fuel-grade ethanol production. So there is a flow chart. I hope this is visible. So this is the fuel-grade ethanol production from biomass. So what are the main steps? So here molasses are coming, acid catalyst is present, ammonium salt is present, and water is given in the dilution tank. Okay, so they are going to a reactor where yeast is given. Right, where yeast is given. So they are producing 12 to 15% of ethanol. Okay, they are going to the vent reactor where off gases are released, and the product is going into the distillation column. From bottom, The animal feed, that is the residue, is collected from the top 50% ethanol and water, and along with the aldehyde goes into the second distillation column, where there is fused oil, that is the higher alcohol. From top also the light end products are collected, and bottom product is recycled back to the previous distillation column. Then the product is going to the dehydration unit, right? Then the benzene is stripped, then it goes to the stripper where benzene is stripped, and from bottom product is the fuel grade ethanol we are collecting. Okay, so from the dehydration tank we are collecting the fuel grade ethanol. So top product is going into the benzene stripper where benzene is removed, and then it goes into the final reactor from where wastewater is collected. So this is the flow chart for fuel grade ethanol production from biomass. So you have to remember very carefully the flow charts. Okay, so question will come from the flow chart also. So you have to be very careful with the flow chart and the process. Okay. Next question is, what are the co-product and byproduct of HDO process? So HDO process means hydro hydro sorry this is hydro deoxygenation. Okay, this is an alternative to the transesterification process, from where green diesel or renewable diesels are the major product. So the co-products are propane and naphtha, whereas byproducts are carbon dioxides or carbon oxides and water. Okay, so the main product is the green diesel, obviously. So main product is the diesel, either green diesel you can also say. And along with the co-product is propane and naphtha, and byproduct is CO2, CO and water. Next question, what are the examples of platform chemicals? What are the examples of platform chemicals? So the example is, platform chemical example is ethanol. You will see the structures from the slides. I am writing the names only. Ethanol, then glycerol, then xylitol, sorbitol, lactic acid, hydroxypropionic acid, then levulinic acid, then succinic acid, and furfural, then HMF, that is the hydroxymethyl furfural, then FDCA, furan dicarboxylic acid, FDCA, furan dicarboxylic acid, etc. Okay. So there are many other platform chemicals also. These are some of the examples. You learn the chemical structure of each and every chemicals from the slide that has talked about that. Next, how is ethyl acetate produced from ethanol? How is ethyl acetate produced from ethanol? So, ethanol structure is this. It is burnt in the air and it will produce acetic acid, right? Will produce acetic acid. Then again, we are reacting with ethanol and some dehydrogenation happens. We are okay, so we are reacting with ethanol and dehydration happens, and that will lead to the production of ethyl acetate, that is CH3COOCH2CH3. That is the ethyl acetate. Okay, this is the reaction. Next question. At low temperature, ethanol conversion is insufficient. At low temperature, ethanol conversion is insufficient. Is it true or false? The answer is true. Okay, at low temperature, ethanol cannot convert properly. Next question. Dehydration of ethanol happens at low temperature and less time in adiabatic condition. Is it true or false? Dehydration of ethanol happens at low temperature and less time. So ethanol dehydration process can happen in two ways. That is, one is the adiabatic way and other one is the isothermal process or isothermal way. So here the temperature for adiabatic case, the temperature is maintained from 720 to 770 Kelvin, and here it is maintained to 600 to 650 Kelvin. Okay, and time required is 6 to 12 months. And for isothermal case, it requires 1 to 6 months. What I have asked, dehydration of ethanol happens at low temperature and less time in adiabatic composition. It is not true because it is happening in isothermal condition. It is false. Next question, 2 moles of methanol dehydration produces what? So, if 2 moles of dehydration, 2 moles of ethanol go into dehydration. What will happen? It will produce diethyl ether. So this is the diethyl ether and obviously the water. So the answer is B. Right? Next question. Explain the glycerol dehydration reaction. Explain the glycerol dehydration reaction. This is not the dehydration, this is the hydrogen. So the reaction is glycerol, that is C3H5 OH whole 3, and the hydration happens. 3 moles of water is added. It will produce 7 moles of hydrogen and 3 moles of carbon dioxide. Okay. So this is the hydration reaction of the glycerol. Next, at 470 to 550 Kelvin during glycerol hydration, other unwanted reactions become kinetically fast. Is it true or false? The answer is false, because if we maintain the temperature at this range 470 to 550 Kelvin, the unwanted reactions become kinetically slow. So the answer is false. Next question. How acrolein is formed from glycerol? How acrolein is formed from glycerol? So there is glycerol, that is C3H5OH whole 3. Where during the dehydration, it will lead to the production of this compound. Again, the dehydration happens and it will produce acrolein. Okay. So this is the structure of the acrolein from glycerol. Next, what is produced after glycerol dehydrogenation followed by methanol reduction? What will be produced after glycerol dehydrogenation followed by methanol production? So, glycerol dehydrogenation happens and followed by methanol reduction, right? So, methanol reduction means one CH3OH will be taken out and it will produce this. This is ethylene glycol. That is Eg. So the right answer is Eg. Next question. What are the derivatives of succinic acid? So what are the derivatives of succinic acid? The first one is the tetrahydrofuran, that is THF. Second one is the butyrol acetone. Third one is the butanediol. And the last one is the pyrrolidones. Okay, so these are the derivatives of succinic acid. Next, explain the reductive amination process of succinic acid. So, structure of succinic acid is like this. This is succinic acid. Okay, and now what will happen? Reductive amination. Right? And now it will produce so this are the results. Just a minute. So the first product is this is 1,4-diaminobutane, right? Also, it can produce this structure, that is succinomide. Succinomide. Then it can produce succinonitrile. Okay, and the last product is 2-pyridine. Okay, so these are the products of reductive amination process of succinic acid. Next, how fumaric acid is produced. How fumaric acid is produced. So, Now, so what is the succinate acid structure? This one. So this is succinic acid. Now we are doing dehydrogenation and cyclization. So what is the product? Product is this is maleic anhydride. Next, we are doing hydrolysis. It will produce maleic acid. Now from this we can produce fumaric acid. So this is the reaction of production of fumaric acid. Next question. Hydrogenation of succinic acid produces THF. Hydrogenation of succinic acid produces THF. The answer is true. Tetrahydrofuran. So from succinic acid, if we do the hydrogenation and cyclization, it will produce tetrahydrofuran. Okay. Next question. What are the purification techniques of succinic acid? What are the purification techniques of succinic acid? The answers are electrodialysis, precipitation, and extraction. So succinic acid can be purified in this way: electrodialysis, precipitation, and extraction. Next, how HMF is produced? So, biomass, hexose, sugars, like those found in cellulose, hemicellulose, and starches can be dehydrated to produce furan compounds like HMF, that is hydroxy methyl furfural. Next question. What are PET and PEF? What are PET and PEF? So, FDCA, that is furan dicarboxylic acid, and TPA, that is terephthalic acid, has similar kind of structure, chemical structure. Okay, so polycondensing TPA with ethylene glycol results in the production of PET, that is polyethylene terephthalate. Similarly, FDCA polycondenses with ethylene glycol produces PEF, that is polyethylene furanoate. Okay. Also, there is an equation. So if you follow this very carefully, you will understand that first HMF, that is the hydroxymethyl furfural, gets oxidized, produces FDCA, right? Furan dicarboxylic acid. Yes. Okay, so this is the HMF structure. It gets oxidized and produces FDCA, furan dicarboxylic acid, and it gets polycondensed with ethylene glycol, produces PEF. This is the structure of the PEF, polyethylene furanoate. Similarly, p-xylene is the basic chemical. It gets oxidized and produces TPA, that is terephthalic acid, and it is polycondensed with the ethylene glycol and produces polyethylene terephthalate, that is PET. Okay, so these are the two polymers coming from two different chemicals, but who has chemicals who have almost same chemical structures, right? So this is the difference. Next question. At room temperature, conversion of HMF to FDCA is a favorable reaction. At room temperature, conversion of HMF to FDCA is a favorable reaction. Is it true or false? The answer is true. It is favorable reaction. Next, how La is produced? La is the levulinic acid. So, HMF, that is the HMF, that is the hydroxymethyl furfural. The structure is this. So there's a benzene ring and There is not, it is not a benzene, sorry. So it is the 5 carbon ring, and so this is the HMF. It reacts with water, that is hydration happens, and it produces levulonic acid, that is La, plus some amount of formic acid. Okay, this is how La is produced. Next question, what is the correct order of the production? What is the correct order of the production? So from fructose, formaldehyde, then xylose, then furfural. I am showing you the link here. So here you can see that's fructose. From fructose, formaldehyde is formed, then it converts to xylose, and then it produces furfural. Okay, so this is the right order, not this fructose, furfural, formaldehyde, xylose. Okay. Next question. Fructose can be converted to furanics at efficiencies between 49 to 57%. Fructose can be converted to furanics at efficiencies between 49 to 57%. Is it true or false? The answer is false, because the efficiency rate is between 38% to and 47%. Okay, so the answer is false because I have written it as 49 to 57%. Next question, how FDCA is produced? How FDCA is produced? So from hydromethoxy furfural, oxidation happens, and it produces FDCA, that is furan dicarboxylic acid plus water. Also RMF, that is methyl furfural with a methyl group or with a alkane group is oxygenated. It also can produce FDCA and also the alcohol. Okay, so this is the production step for the FDCA. Next, what is the purpose of using A distillation columns in upgradation of furanics? So the answer is here. So here you can see that in the upgradation of Furanic step, 8 distillation columns are used. Pressure is gradually reduced in order to simplify the recovery of end products, light end products, that is methanol, methyl formate, and formaldehyde. So first 5 distillation columns are dedicated to light ends recovery and operates between 25 and 1 bar. And final 3 distillation columns are for the recovery of, and upgrading section dedicated to the recovery and upgrading of HMF, HFF ethers, levulinic acid, LA esters, and operates between 0.2 to 0.015 bar. That means very low pressure and elevated temperature. Right, so you can see that furanic solvent 2 means enters into the first column, it goes into the second column where methanol and water are separated. Similarly, the top product also goes into third column where from bottom methanol and water are separated. Top product goes into the second. Fourth column, top is collected for MEOH and methyl formate, and bottom is also collected for the methanol. So this all these 2, 3, 4 column products produces the methanol pool, and the bottom product of second column it goes into the fifth column from top NaOH, H2O, furfural are methanol, H2 and furfural are collected. Bottom product goes into the sixth column. Top product from six top column product is product goes into the seventh column where LA esters and furfural waters are separated, and bottom product of sixth column goes into the last column, and from where HMF ethers are separated from the humans, and further this HMF is oxidized to produce FDC and then polycondensed with ethylene glycol to produce PEF. Right? So this is the answer. Purpose of the 8 columns. Next, what are the pre-treatment methods used for food waste to enhance the biogas production? What are the pre-treatment methods used for food waste? If W means the food waste. So the answer is physical, chemical, physicochemical and enzymatic methods are used for the hydrolysis of food waste. So if W is the food waste. If W is the food waste. So physiochemical and enzymatic methods are required in the pre-treatment section for the hydrolysis of FW to enhance the biogas and biochemical production. Next question, explain the types of foods. Now explain the types of foods. So there are 3 types of foods. carbohydrate rich wastes, protein rich wastes. The third one is the fat or oil rich wastes. Okay. So if you want to go in the details, you will see that this is the types of food waste. So carbohydrate rich food waste include molasses, wheat, spent grains from breweries, whey, then apple pomace and olive pomace. Okay. Protein rich wastes include soybean meal, linseed meal, yeast breweries, yeast hydrolyzed corn strip liquor. And slaughterhouse waste and chicken oil come under the fat or oil-rich waste. Slaughterhouse waste and chicken oil. So these are the details of the or examples of the three different types of food waste. Next, explain the multi-dimension approaches to produce bio-based products from food waste. So if we go to the lecture slides, you will see the multi-dimension approach, right? So the first food waste we can see is the animal food. Then just a minute because I think it is not visible to you. So let me open the lecture.
converted into platform chemicals or in
So now you can see, I think. So that is, yeah. So food waste is transferred for the animal feed. Then after anaerobic fermentation, it produces hydrogen, methane, bioethane, fatty acid, biofertilizers. After solventogenesis, it produces biobutanol, bioethanol. After bioelectrochemistry, it produces chemicals, biopolymers. Then after biomicrobial electrolysis cells, it produces hydrogen. And lastly, after yeast or fungi fermentation, it produces ethanol and biodiesel. So these are the multidimensional approaches to use the food waste in circular bioeconomy. Similarly, this ethanol and biodiesel effluents can also be used from this anoxygenesis, which produces bioplastics, algae conversions, which produces nutraceuticals, biodiesel, biomass, animal feed, bioelectricity, and bioregenerated from the microbial fuel cell. Okay, so these are the multidimensional approaches. Now, next question. Name of the products after anaerobic fermentation of food waste. Name of the products after anaerobic fermentation of the food waste. The product name includes the majority of the resulting compounds products are acetic acid, propionic acid, butyric acid, isobutyric acid, and valeric acid. So these are the major products of the anaerobic fermentation process of food waste. Next question, write the correct order of steps for anaerobic fermentation. So the correct order is first hydrolysis of the food waste, then acidogenesis, where aldehydes, alcohols, VFAs are produced. Okay. Then acetogenesis, where acetate, ethyl acetate are produced. Next, dehydrogenation, right, where H2 is going out. And the last process is the methanogenesis. Here methane is produced. So these are the sequential steps for anaerobic fermentation of food waste. Next, write the types of bacteria used for anaerobic fermentation. So the types of bacteria is hydrolytic, acetogenic, hydrogen producing, acetate forming microbes are required. Okay. Then hematogens, no, sorry, it is not hematogens, it is homoacetogens. The third type is the acetoclastic methanogens, and the last one is the hydrogenoclastic methanogens. So these are the type of microbes or bacteria used in anaerobic fermentation. Next, methanogenesis is suppressed to enhance VFA and hydrogen production in anaerobic fermentation. Methanogenesis means the production of methane. So this process is suppressed to enhance VFA and hydrogen production, which this VFA and hydrogens are produced mainly from the acidogenesis process. So methanogenesis is suppressed, and it is true. Okay. Next question. The two-stage approach, which physically separates two processes, appears to be effective. And which are the processes? The answer is acetogenic and methanogenic. Okay, so this is very confusing. Acetogenic and acidogenic are two different methods. So this is the acidogenic and methanogenic. Next, what is dark fermentation? So dark fermentation is a microbial reaction in which anaerobic bacteria create hydrogen from organic materials via the glycolysis pathway, or in presence of glycolysis pathway, in absence of light. Okay, so there are various bacteria that are also used for dark fermentation. You can include that also, that they are Escherichia coli, Enterobac Enterobacteriogens, then Citrobacter intermedius, Enterobacter cloacae, then Ruminococcus, then Clostridium bacterias, etc. Okay, the reaction is, so this is glucose C6H12O6. The glycolysis happens in absence of light. It produces citric acid, carbon dioxide, and hydrogen. This is the dark fermentation. Next, pathways have higher biohydrogen outputs than alcohol and lactate processes. The answer is acetate and butyrate. So acetate and butyrate pathways have higher biohydrogen outputs than alcohol and lactate processes have. Next question. What is electrofermentation? So it is a new hybrid technology by combining traditional fermentation with electro microbiology. So it employs polarized electrodes to divert the flow of a tiny number of electrons into or out of the medium. Okay, so electromagnetation, it uses electrons from organic material in the medium because electron exchange at the polarized electrode is low compared to microbial electrosynthesis. Okay, so the details is given in the such lecture slides. So you can learn from that. So in the dark fermentation, it was happened in absence of light. Electrofermentation means it is happening in the presence of electrodes or polarized electrodes. Next comes the photofermentation. So photofermentation, here light is used. Here photofermentation means from the name itself you can understand it uses light. So here light is utilized as a supplementary energy source. Okay, so here also the expression is obviously same, but it is happening in the presence of light. So acetic acid is produced in presence of light. It produces hydrogen and carbon dioxide, and this is called the photofermentation. Next, what are the uses of carbohydrate-rich food wastes? What are the uses of carbohydrate-rich food waste? So carbohydrate-rich food waste means they contain glucose, sucrose, lactose that can be used as a carbon sources for fermentation process. So certain compounds like succinic acid, fumaric acid, malic acid, 3-hydroxypropionic acid, then glutamic acid, itaconic acid, aspartic acid, xylitol, arabinitol, etc. can be produced through the bioconversion of glucose, xylose, arabinose, lactose, and other sucrose. That means the carbohydrate-rich food waste. Okay. Next question: explain the biodiesel production from poultry waste. So, in the poultry, what happens? In the poultry, you know that waste chicken fat is there, right? It can do extraction, then esterification, then trans-esterification, and produces biodiesel, right? In the poultry, there is also the waste egg shells, right? They can go first grinding and produces reduced catalyst powder, reduced catalyst powder, and they are doing transesterification with the help of catalyst and produces biodiesel. So this is the biodiesel production from poultry waste. So this is from my side. I hope we will find this session helpful for doing your last week assignment. And we have another class, I think, the last class, the end class for this session of uh, chemical process technology. And till then, goodbye.